Well, hello everyone, and thank you for coming along to hear this talk today. As Judith has just said, my name is Martin Hendry. I'm an astronomer from Glasgow University in Scotland in the UK, and I'm here to talk to you today about the topic, did we really land on the moon? Now, what I spend most of my time doing is studying very exotic and very bizarre objects like black holes and exploding stars. And for many years, as well as researching those fields, I've been doing outreach to schools and to the public on those areas of astronomy and astrophysics. But over many years, I was finding that as I give public talks or schools lectures on these themes, somebody would ask me, did I think we really landed on the moon? And I became quite fascinated why more than 40 years after the moon landings happened, why so many people were interested in that question and perhaps suspected that maybe it was all hoaxed and faked by NASA back in the 1960s. So what I'm here to tell you today is that I don't think it was faked. So I should lay my cards on the table and begin by saying there's a very short version of this talk which goes something like this, and then we can all go home. But in a way, the main point of why I'm here is to encourage you to think about it for yourself. And in fact, I've just taken on a new role within the UK's Science and Technology Facilities Council that funds all that research into black holes and gravity and cosmology, all the things I normally do. But what they're looking for me to do is to be a kind of ambassador for those areas of science which our Research Council funds. And really, in a way, what I'm looking to do in that position is just to get people thinking a bit more about how science works in the first place. Sure, we find out lots of cool things about the universe, and a bit like Judith was saying, 5 years from now we'll be finding things that no one's even thought of yet. So it's kind of hard to anticipate future developments in science. But the one thing we can point to is that the scientific method, the way in which we do science, hasn't really changed so much over a very long time. So what I'm going to encourage you to do in this short presentation is to think about the question, did we really land on the moon? And reach an answer not just because of what I say, because I'm a professional scientist and I should know better, but instead I want to see what you think. And I'd like to encourage you all to really just have a little think about this question and see what conclusion you reach for yourself. So like I say, what got me into this was over many years people asking me the question and my recognizing that I didn't really know enough about it to offer much of a professional opinion. My gut feeling was that yes, we really did land in the moon because, you know, it would have been impossible for NASA to pull off such an elaborate hoax. But there did seem to be people out there who were claiming the contrary. So I began to dig a little more into this and came across a documentary program which was casting serious doubt on whether this great adventure that took place in the late 1960s and early 1970s had really happened at all. So I want to begin by showing you a short extract from that documentary program. There's been several more like it, and to be fair, there's also been documentary programs that set out to rebut the evidence in the one I'm going to show. So I'm by no means doing this for the first time. There's plenty of people out there who've attracted some attention to this topic in the past. But nonetheless, it's an interesting one. I hope you'll find it so as well. And as I said, to begin, let's just take a brief look at a short extract from this Fox television program, Conspiracy Theory, Did We Really Go to the Moon?
The following program deals with a controversial subject. Tonight.
Liftoff. We have a liftoff. At 1 small step for man.
Man landing on the moon.
1 giant leap for man.
But believe it or not, some people say it never happened.
This whole thing was a fake. The flag flaps on the moon where there's no atmosphere.
During their 8-day voyage, the Apollo 11 astronauts saw spectacular views of the Earth, floated in a weightless environment, and supposedly went where no man had gone before.
They're looking good down and half.
Millions of people watched on television as the lunar lander touched down, and these unforgettable words were spoken.
At 1 small step for man. 1 giant leap for man.
But even today, There are those who claim that believing in man's one small step requires one giant leap of faith.
I think it was an intuitive feeling that what was being shown was not real.
Casing observed that despite the clarity of deep space, the stars were missing from the black lunar sky. He saw the American flag waving, even though there is no air on the moon. And he discovered that there was no blast crater beneath the lunar lander. As outlandish as it might seem, it has been estimated that as many as 20% of Americans believe we never went to the moon.
So that's a lot of people. So just what exactly is lying behind these claims? Well, we heard some commentary there from Bill Casing, who in the 1970s was one of the chief protagonists of these moon hoax conspiracy theories. Another person around that same time, and indeed to the present day, is Bart Sibrel, who in the 1990s put together a DVD called A Funny Thing Happened on the Way to the Moon, which very firmly put forward the notion that it was all filmed in some studio. And Bart Sibrel has achieved more recently infamy on the internet because there's a video clip which you could find on YouTube, which is where Bart Sibrel was going in search of some of the Apollo astronauts, in this instance Buzz Aldrin, who was the second person to land on the moon, and he was challenging the Apollo astronauts to swear on the Bible that they had really gone to the moon. And this is what happened when he tried to get Buzz Aldrin to do that.
You're a coward and a liar and a thief. Did you get that on camera?
That's maybe worth watching again. Bear in mind that Buzz Aldrin was in his late 70s at this time. He still packs a fairly mean left hook.
You're a coward and a liar and a thief. Did you get that on camera?
Much as I can understand Buzz Aldrin's reaction, I think as a scientist what I want to try and do is approach this in a more cool and calm and objective way. As my wife put it when I saw that Fox television documentary, once my blood pressure had returned to normal levels, what she recommended I should do was try and think of ways in which, through simple science experiments, we can test some of the ideas of the conspiracy theorists. So that's what I'm here to talk to you about today. There isn't time to go through all of them, but what I'm going to do at the end is give you a web address where I've put together a lot of resources, and I've worked with many schools in the UK to essentially carry this out as an extended science project over maybe a few months. So perhaps some of the school groups who are here today might wish to consider doing that for themselves in the future. So let's take a look at what I would regard as the kind of top 10 conspiracy theories, and we'll do our best to get through a selection of them in the time we have today. I think number one in the list is undoubtedly the waving flag, the fact that you see the flag waving in the video footage from the moon. It's the one which the conspiracy theorists say is the real chief piece of evidence in favour of it being fake. That's what they say anyway. They also point to the fact that there are no stars in the photographs, which in their view is suspicious because one should, as they put it, be able to see stars in the clarity of deep space. And then they point to, oops, let's not advance quite so quickly, they point to some discrepancies, in their opinion, in the shadows in the photographs, the fact that the shadows don't appear parallel, which in their view is an indication that there are multiple light sources contributing to the photographs, and therefore, in their view, that means that it was filmed on Earth and not on the moon. They also point to the fact that the film of the astronauts, when played back at a faster rate, looks, in their opinion, as if it was being filmed on Earth, and therefore they conclude that what actually happened is it was filmed on Earth and then slowed down later to make it look as if it was on the moon. Then there's various other photographic anomalies, as they would have it. The fact that some of the crosshairs in the images, which according to NASA are on the lens of the camera, well, sometimes they actually appear behind things in the photographs, which they would claim is evidence that NASA were somehow tampering or doctoring the images. And then there's the fact that you can see detail in the astronaut's spacesuit even when they are standing in pools of shadow. And if, in their view, there is only one bright source of light, that is the sun, then the hoax theorists challenge the fact that you can see these details. They say that the astronauts should be standing in shadow, and therefore you shouldn't see those details on their spacesuit. Then there's various issues that they identify to do with the dust. The fact that, for example, you can still see well-formed footprints around the lunar module, which they claim would have been impossible because all the dust should be blown away, in their opinion, by the exhaust of the lunar module rocket engine. And that same rocket engine should, according to them, have produced a sizable blast crater beneath the lunar module. Then they also point to the radiation belts around the Earth, which they say, no pun intended, is a real piece of killer evidence in favour of the conspiracy theories, because they would say that the astronauts would never have survived the journey to the moon and the passage through those radiation belts. Then there's one or two further photographic anomalies. For example, the fact that you see the lunar module in some images and not in others, which appear to be taken from essentially an identical location. And this is puzzling to them because the lower stage of the lunar module actually stayed behind on the moon. And therefore, why is it missing from the photograph on the right? And related to that, as I said, the lower stage stayed behind. Well, the footage of the upper stage ascending from the moon, which NASA says filmed from the lunar rover, the little moon buggy that the astronauts had in the later missions, according to the hoax theorists, that looks suspicious too, because you don't see any fuel jet from the exhaust of the lunar module. So that's a little cross-section of some of the ideas. And I guess my experience has been that when people look at these 10 conspiracy theories, or maybe others that they've heard about or read about, then it's maybe quite understandable that they should have some doubts. And indeed, it's maybe worth pausing at this point to see whether anyone here is harbouring any suspicions that in the light of all of these conspiracy theories that perhaps the moon landings were faked. Anyone like to express a view? Do we have any doubters in the audience now after all those? Well, if everyone thinks the moon landings really happened, again, maybe we can all go home. But in the spirit of getting you to just think a bit more carefully about the question, let's take a look at one or two of them and see how I, as an astronomer, would encourage you to think about the science behind the hoax theory. So if we start with the waving flag, let's begin by seeing what the television show had to say about that one.
If there's no air or wind on the moon, why is this American flag waving?
The fact that the flag flaps on the moon where there's no atmosphere means that there must have been a little blast of wind out in Area 51 where they shot this.
Could these questionable images simply be the result of astronauts struggling to plant the flag into the lunar surface? Or is there more going on than meets the eye?
I think it does tell you a lot about just how difficult it might be for someone confronted with these conspiracy theories to make up their mind on what they should believe and what they shouldn't believe. Because conspiracy theories come in many levels and many layers. And indeed, one of the best sites I've come across which debunks some of these moon hoax conspiracy theories is actually written by people who think that the real cover-up is that NASA discovered evidence of alien life on the moon, and that it suits NASA's purposes to have the moon hoax theorists as a distraction from those conspiracy theories. And indeed, the authors of those pages describe people like Bill Kaysing as the sort of people that give conspiracy theorists a bad name. So that's what you're confronted with. So basically my moral here is that the challenge of 21st century science is to be able to sift the information you find and separate the good science from the not so good science. So let's see if I can help you do that today. Let's have a think about what we would expect a waving flag to do on the moon where there is no atmosphere. Well, first of all, if we look at this video clip, we can see that the astronauts are planting the flag in the ground, and sure enough, it is indeed waving from side to side. If there's no atmosphere in the moon, we'd basically expect the flag to droop, to just sag and hang down the way a flag would on Earth on a windless day. Now, I think the PR people in NASA figured that that wouldn't look too good for the watching millions back home, so they designed the flag to have a rigid horizontal crossbar so that the flag would be extended. It would look better for the photographs. And moreover, the flag wasn't made of cloth, it was made of plastic with a semi-rigid ripple effect so that again it would look more photogenic for the cameras. But I think the real question here is, can the conspiracy theorists show me some video footage where the flag is flapping and yet the astronauts are off doing something else? Because the only footage I've ever seen where the flag is moving is when they're in the process of planting it in the ground, or they've just let go of the flagpole after planting it into the ground. So my scientific explanation for this one is that the reason the flag is flapping is because they're twisting the flagpole back and forth to plant it in the ground, and that sets up the motion of the flag itself. But don't take my word for it. Let's have a look at a little experiment that we constructed, short of going to the moon ourselves, to try and investigate that theory that I've just put forward. Would the flag flap on the moon where there's no atmosphere? But what we basically did was to pump the air out of the jar, or as much as we could without equipment. So when you see it saying 1/10 of atmospheric pressure, that's because we've pumped 90% of the air out of the jar. And what I'd like you to notice is that when most of the air is gone from the jar, the flag flaps many more times than it does when there's air in the jar. If you remove most of the air, you greatly reduce the friction. There's no air resistance. There's still some friction between the flag and the flagpole, so it does stop eventually, but it takes quite a bit longer than when there's air in the jar. So the curious thing about this, in my view, it actually argues that the waving flag, instead of being the chief piece of evidence in favour of the hoax theory, it's actually the best evidence we have that they really were on the moon. Because a flag on Earth in Area 51 or anywhere else simply wouldn't do what we see the flag doing. It wouldn't flap for as long because there would be air resistance to slow it down. Now, I wouldn't say that this proves that we really went to the moon, but I think it makes a serious dent in the chief argument of the conspiracy theorists, and in my view, it's all because they haven't properly understood what a flag would do in a truly airless environment. You've got to think through the science, ideally construct a little experiment like we did, and see what you find. Conversely, for example, if you look at some footage of a flag where the astronauts aren't just planting it in the ground, in fact in this case they're on board their spaceship about to head off home, this is just the final seconds before Apollo 16 left the moon, and we can see that sure enough the flag does move as it's blasted by the exhaust from the upper stage of the lunar module, which in a sense also relates to number 10 in my top 10 list. Just because you don't see an exhaust flame doesn't mean there isn't an exhaust or that it doesn't have an effect. Indeed, often back home what I do to demonstrate this is to consider using a Bunsen burner, which again many of you will have used in school, and you might have had experience of this yourself. If you're in a brightly lit room, it's sometimes quite difficult to see the flame of the Bunsen burner. So basically I think the waving flag is a real red herring. I think in the case of this one, the conspiracy theorists have just got it completely wrong because they've misunderstood the basic science. What do you think? Go away and have a think about it for yourself. But it does lead us on to maybe the next topic that's worth considering, which is the absence of stars in the photographs. Now what we see here is quite a famous bit of footage whereby one astronaut is filming his colleague as he jumps off the moon's surface, and then he sort of floats down. Well, float's really not the correct word in this context. He drops down, but in the lower gravity of the moon, so it takes him longer to accelerate towards the moon's surface than it would do if you were on the Earth. But the two things to note are that first of all, the flag is just perfectly still throughout all of that, and secondly, you don't see any stars in the photographs. The conspiracy theorists would challenge this absence of stars and say that that, in their view, is highly suspicious, because in the clarity of deep space, in the words of Bill Casing, one should be able to see the stars in the photographs. Well, is that really true? Now, the puzzling thing I find about all this is that Bart Sibrel is a photography expert, or he claims to be at any rate. So surely Bart Sibrel should realise that if you take a photograph on a moonlit night, it's pretty hard to see any stars. Here's a photograph taken in Tucson, Arizona, from an observatory near to there. Actually, Tucson, although it's a big city, the light pollution, as we call it, isn't too bad around there. Although there's a lot of street lights, most of the light doesn't shine up and illuminate the sky. That's good for astronomy. But actually, the biggest source of light pollution in this photograph isn't the street lights, it's the moon. And any professional astronomers know that the one time in the month when you don't want to go looking at faint stars or galaxies is when there's a full moon. The moon is just too bright by comparison. If you want to see the moon and the stars at the same time, what you need is a long exposure photograph. And here's one that I and my colleagues took down in Cornwall in the southwest of the UK. And you can see that the moon is elongated in shape. That's because we needed to take a long exposure in order to bring out the detail of the stars, which appear as little trails, because during the photographic exposure, the Earth is actually turned a little bit. If you want to see the moon and the stars at the same time, what you need is a long exposure photograph. And here's one that I and my colleagues took down in Cornwall in the southwest of the UK. And you can see that the moon is elongated in shape. That's because we needed to take a long exposure in order to bring out the detail of the stars, which appear as little trails, because during the photographic exposure, the Earth is actually turned a little bit. As a consequence, both the moon and indeed the streetlights of Penzance are horribly overexposed. So the photographs taken by the astronauts, I would allege, don't show any stars for the very simple reason that they're short exposure photos, and the background light from the moon's surface itself is illuminating the scene far more greatly than the stars themselves. Although curiously, if you actually go and have a look at the NASA archives where many of these images are stored, what you find is that downloading the images, increasing the contrast and inverting the colours, maybe it's a little hard to see, but does reveal some little black dots in the photograph. Now, for all I know, those could just be defects in the photographic film, but they might be stars. I guess my main point is that these are simple experiments and investigations that people can carry out for themselves. But I think it's an interesting topic, the absence of stars, to really get you thinking about how photographs work and how the physics of photography influences this question. Now, time is short, so as I say, there's many of these topics that I greatly encourage you to go away and have a look at for yourself, but I'm going to jump ahead a little bit now, and I'm going to talk to you about dust problems. But I want to talk about this one because there's some very good science here and some quite fun experiments that we enjoyed putting together. And many of the schools with whom I've worked in the UK, they've done some wonderful project work on this topic for themselves. So basically, let's have a listen to what the TV show says first.
In the end, there's one set of evidence that is irrefutable, and that is that there are footprints, boot prints, still on the lunar surface.
But conspiracy theorists say that the footprints themselves are suspicious.
The surface appears to be very fine-grained as you get close to it. It's almost like a powder.
To have a powerful rocket engine blast the surface of the moon, blasting away all of the dust, and then find footprints surrounding the lunar lander, that to me would be an impossibility.
Photo after photo reveals that the lunar surface surrounding the LEM is covered with footprints.
So Bill Casing is having us believe that the powerful rocket engine on Apollo 11 and the later missions would have blown away so much dust that you couldn't have any footprints, and moreover, that you should have had a major blast crater underneath the lunar module? Well, to try and address that one, let's first of all have a brief look at the final descent of Apollo 11. Long before the time of many people in the audience, I was only about 18 months old myself, but this is where Neil Armstrong and Buzz Aldrin are piloting the Eagle Apollo 11 lunar module down onto the moon's surface. And the main thing to note here is that they're not really descending very rapidly. They're going mainly sideways, in fact. And the reason for that was very important. There was real concern that they might wind up landing on a sizable boulder which would tip over the lunar module and end the mission very fast. So they were in the business of trying to slow their descent as best they could in order to ensure a safe landing. So this notion of a powerful rocket engine decelerating them very quickly, as was alleged by Bill Casing, doesn't really seem to add up. And again, don't take my word for it. If you think about what the effect of a rocket engine would be, if it was indeed blasting away at the moon's surface, then the conspiracy theorists would claim that that would make this large crater as well as blowing away all of the dust around. But here's what an engineer from NASA has to say about it.
The fact that there's no blast crater under the limb is one of the most conclusive pieces of evidence that I find supporting the hoax.
In fact, no sign of a blast crater is visible for any of the 6 lunar landings. But lens specialist Paul Fiel says he can explain why the lunar module left no crater when landing on the moon.
The amount of thrust that you need coming out of the bottom of the descent engine is about 1,500, 2,000 pounds of thrust. And all that does is just push dust away. There's no burning or anything like that.
Yep.
So he's saying that there's no burning or anything like that. The crucial thing here is that Paul Fiel, one of the NASA engineers, actually quotes some numbers. Science is all about being quantitative. It's about measuring things. It's about working things out as best you can rather than just making wild guesses or rather speculative answers. So we thought we'd explore that a little bit, and in setting up an experiment, again it was a bit difficult to replicate the exact conditions you would have had on the moon, but what we wanted to do was to explore just what the effect of the engine of the lunar module would have been on the dust on the moon's surface. First of all, notice that there are some photos that indicate a small crater. A small amount of dust does indeed appear to have been disturbed immediately below the engine. We'll come back to that point in a moment. But first of all, let me show you our little experiment. We had great fun doing this. We got to build our own lunar landscape first of all, and then populate it with some dust in the form of some flour. And then along comes our lunar module in a moment, and what we're doing is blowing some compressed air through the lunar module, aiming it directly downwards to try and simulate the effect of the engine disturbing the dust immediately below the lunar module, but not anywhere else. And then in a few seconds you'll see our brave astronaut coming along, and sure enough, there's still plenty of dust around for him to make footprints in our lunar surface. Now, I know it's not exactly very rigorous science, but nonetheless, what we're trying to explore here is how the absence of an atmosphere in the moon would change things compared with how dust would behave on Earth. And to look further at that, we'll not just think about the effect of the lunar module landing, but also the lunar rover, the moon buggy, which the Apollo astronauts used a bit later on. And before we get to the moon buggy, let's have a watch of a brief video clip of a rally car racing down here on Earth. So what we see going on there is that as the rally car races along the dusty road, the wheels are turning very fast. Those wheels are disturbing dust on the road, which in turn can then transfer some of the energy of the car moving along to more dust. That creates this billowing cloud of dust, but there's a very crucial element that makes that possible, which is the air molecules in between the dust particles. Now, this is a phenomenon which you can study in a variety of different ways. No less a person than Albert Einstein actually did some of the theory related to this about 100 years ago. And the phenomenon is called Brownian motion, the random motion of the dust particles which bump into the air molecules, which in turn bump into more dust particles. Before you know it, you've got a billowing cloud of dust. And again, I could have showed you similar footage of, say, a helicopter landing, or indeed a spacecraft taking off from the Earth. You get a billowing cloud of gas and dust produced by such a dramatic event. What about on the moon? Well, let's have a look at what the lunar rover does on the moon. First of all, notice there's no sound this time, but look carefully at what the dust is doing. The dust is not producing this large billowing cloud. Instead, it is indeed being thrown up by the wheels, but it spreads out a little, but not nearly so much. And in fact, what the dust does is forms a particular form of mathematical curve called a parabola. Now, that parabola is the shape of curve that, say, if I take a coin and I throw it over here, the coin will go up and then it will go down. It will follow a curving arc. On Earth, dust doesn't do that because dust floats because of air resistance again. On the moon, dust will follow a curved path just like a coin or a rock or something much heavier. In fact, it won't follow exactly the same path as it would on Earth because the gravity is lower. But crucially, if you think of the lunar module landing or the lunar rover chugging along the moon's surface, in both cases, you don't have the air to help create the billowing cloud of dust that we saw with the rally car. So the presence of the footprints which the Apollo astronauts made would seem quite compatible with the absence of an atmosphere on the moon. Moreover, as I said, you can measure the curving arc of the dust thrown up by the lunar module, and based on the curvature, you can work out what the gravity is. That's a really quite challenging little experiment, but something you might want to have a go at for yourself. There's video capture software, which I guess most schools would have access to, which would allow you to analyse the motion of the dust on the footage. We've had a look at that, and sure enough, it gives you an answer consistent with the lower gravity of the moon. And I'll come back in the final few minutes to this idea about the low gravity on the moon as well. So the last of the main topics I want to briefly look at is, I'm sorry I don't have time to go through all 10, but as I said, the resources are all there on the web, as we'll see at the end, and I encourage you to go away and have a think about these for yourself. But let's just have a brief look at radiation before we wrap up.
Any human being traveling through the Van Allen belt would have been rendered either extremely ill or actually killed by the radiation within a short time thereafter.
Other than the Apollo missions, no other manned space flight has attempted to pass through this deadly radiation.
What we have to bear in mind is that the radiation damage, both to life and to buildings and so on, caused by those explosions was rather different from the main radiation threat which the Apollo astronauts would have faced. The main radiation threat which the Apollo astronauts had to deal with was charged particles coming from the sun, what we call the solar wind. Now, these are trapped by the radiation belts around the Earth, and that's good news for us because it stops them reaching the ground and harming us. But in fact, those charged particles are basically protons. They're the nuclei of hydrogen atoms because the sun is mainly made of hydrogen. Now, radiation comes in a variety of forms. You've got protons, like the solar wind. You've got the nuclei of helium atoms, which are known as alpha particles. And then you also have another form of radiation called beta particles, which are like the positive counterpart of the electron, a positron. In addition, you have ionizing radiation, which is in the form of light, but light of very high energies, ultraviolet, X-rays, and gamma rays. Gamma rays in particular are extremely harmful, and moreover, if you wanted to shield yourself from gamma rays, well, you really need several inches of concrete in order to do it. Even X-rays, you need a substantial thickness of lead. That's why if you go to get an X-ray at the hospital, the radiologist will stand behind a lead screen to shield his or herself from the X-ray exposure. But if you want to shield yourself from protons, really all you need is a few centimeters of wood. Now, I do concede that building the Apollo lunar module out of wood would not have been NASA's smartest move, but a few millimeters of aluminium will do the job just as well. And again, a demonstration I normally take to schools in the UK is a source of, well, in fact, it's usually alpha particle radiation, but protons are broadly similar, and a Geiger counter takes some aluminium foil and demonstrates that the foil will shut off most of the signal. But the key message is that radiation comes in these different forms. The sun does produce gamma rays, but in most copious amounts at times of a major solar flare event. Fortunately, there weren't any such major solar flares during the Apollo missions. If there had been, then the astronauts could indeed have been in big trouble. The proton threat from the solar wind is a much more manageable threat. The aluminium shell of the spacecraft was more than adequate. Moreover, they passed through these Van Allen belts fairly quickly in just a few hours on the way to the moon. So ironically, the claim made by the program that no one has been beyond the Van Allen belt since, actually, there's a much greater threat if you're on board the International Space Station. I mean, it's still perfectly reasonable. There's no evidence that the astronauts on board the space station have suffered any long-term harm. But because they are continually being exposed day after day to small amounts of ionizing radiation as they pass through the Van Allen belts, then it's a threat that has to be taken seriously. The way the body reacts to radiation exposure is that if it's not too energetic, not too ionizing, and doesn't last for long, then the body will recover just fine. So that really brings me to a few concluding remarks. Again, there's plenty more to discuss on the other topics I've not had time to cover, but I encourage you to go away and have a look at them for yourself. So let me just wrap up by a few remarks about the counter-arguments that people have often come along with. They've sometimes said, well, couldn't we use the Hubble Space Telescope to look at the moon? Wouldn't that show us images of the lunar landing sites, and then that would settle it one way or another? The Hubble telescope is probably still pound for pound the best telescope we have up there in space. There are bigger telescopes on the ground, but because they've got to look through the atmosphere, they don't give us as sharp a view of distant objects in the universe. The trouble is, though, the Hubble telescope's just a few hundred kilometres above the Earth. The moon is 400,000 kilometres in the other direction. So even though we've grown accustomed over the years to seeing images like this one, that's of Sydney Harbour, or this is Frankfurt Airport, the kind of images that you see in like Google Earth, for example, many of them taken by aircraft, but some taken by satellites. If you use the Hubble telescope to look at the moon, because it's so much further away in the other direction, even the Hubble telescope doesn't have sufficient resolution to reveal the Apollo landing sites. This is an image of the moon taken by Hubble, and it shows a large crater called Copernicus, which is about 100 kilometres across. So each pixel of the image is still about 70 metres across, way bigger than the Apollo lunar landing site. However, in the last few years, there's been a satellite actually orbiting the moon itself called the Lunar Reconnaissance Orbiter. And it sent back some images like this one, which NASA released in July of 2009 to mark the 40th anniversary of the first lunar landings. So according to NASA, that is Apollo 11. According to NASA, for Apollo 14, you get an even better view. You can see the lunar module, footpaths of the astronauts, some of the instruments left behind. Now, of course, again, the conspiracy theorists will probably just say that these are faked as well, but I'm prepared to give NASA the credit that what we are actually seeing is the lunar landing sites. So here's another couple of ways that I would regard as having proof that the moon landings really happened. Lots of video footage was tracked by a network of satellite dishes, radio telescopes on the Earth's surface. There was a movie a few years ago called The Dish about one such radio telescope in Australia. Okay, the movie fantasised the story a little bit, but I know some of the astronomers who worked there in Australia at the time. As far as I know, their story checks out. They say that basically they were getting signals from the moon. They can't say that there were really astronauts up there, but there was something up there beaming those signals back. And then there's all the moon rocks that were brought back, which my geology colleagues tell me, if you look at them under a microscope, they show the unique signatures of billions of years of exposure to an airless environment with lower gravity, no water, but crucially also no air, to erode away the surface of the rock in a smooth manner, the way that it happens on Earth. Then there's a variety of experiments that were carried out to measure the distance to the moon by bouncing a laser beam off the moon's surface. And in fact, one such experiment featured in my very first image, because the instrument that Buzz Aldrin is carrying is this little thing here left behind. It's a laser reflector to ensure that the laser beam bounces straight back. Without that being there, the beam would be too diffuse by the time it reflects off the moon for you to measure anything. Now, there's hundreds of such experiments have been carried out, including by scientists in China. Are they in the conspiracy as well? Again, a question I put to the conspiracy theorists. And then finally, back to this notion of dust and floating dust on the moon's surface, or in particular the fact that dust doesn't float on the moon. Let me just wrap things up by showing you a brief video clip taken by Apollo 15 astronaut David Scott, and I'll let him explain what's going on.
Well, in my left hand I have a feather. In my right hand a hammer. I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
So not only do you see the hammer and feather fall at the same time, the same rate, there's no air resistance to make the feather float, but they do take longer to hit the ground than they would on Earth, and if you measure the acceleration, you get 1/6 that of Earth gravity. Now, we had a student work with us on this to do some analysis of that video footage, and maybe he was just trying to wind us up, but he said what would happen if he did the measurements and he discovered that you got 10 meters per second, which is the gravity of the Earth. So we teased him back and said that that's the point where the men in the dark suits and the dark glasses would come through the door. I'm pleased to say that that was not what he measured, and it's not what's about to happen to all of you today. But to emphasize the fact that there is a lot of stuff out there, and it's hard to know what to believe and what not to believe, let me end with this short video clip, which will give you food for thought as you take away this question of, did we really land on the moon?
That's one small step for man, one giant leap. So, I guess you want to do it again. Okay.
I'm fairly sure that one's a fake though. So let me leave you with the web address where you can download all of this. I've also got that as a tiny URL, which is a bit easier to digest. And indeed, we have as a dedicated email address if anyone's got any questions about moon landing conspiracy theories, or if you come across some evidence that you think maybe backs them up and you want to see what I think, then by all means get in touch. Thanks very much, and I hope you've enjoyed my talk. So I believe we have some time for questions. I'll be very happy to answer any questions people have, and I think there's some roving microphones that will go around to make sure everyone can hear you.
When was the last time like a man supposedly landed on the moon?
I like your use of the word supposedly there. 1972, as I recall, I was about 4 years old, and in fact it is one of the earliest things I remember. I'm not quite sure what I made of it, watching hours of television as these astronauts bounded across the moon's surface. But nonetheless, although I don't remember the first landing, I do remember the last one. It was Apollo 17. There were several more missions planned, but due to budget cuts, they didn't take place. So it's getting on for 39 years since the last person set foot on the moon. We have a question down here.
Where do you get your materials and how do you do research? Like, is it now publicly available? All information about the mission, is it available?
Absolutely. I can certainly point you towards the NASA website, but what I've recognized is that, frankly, these days there's so much information available, it's hard for people to sort out what's useful and what isn't. So what I've set out to do with this webpage here is to collect together some useful resources and starting points. It's not to say that's the definitive information and you need look nowhere else. It's just to be a good launch-off point for you to find other things. So from this webpage, designed to be a launch-off point for all the schools who've undertaken this as a science project, what it takes you to is some NASA web pages, some other web pages which have looked at all of these conspiracy theories and systematically tried to address them, develop projects to study them. So, you know, this one web page, I would contend, should give you plenty of further launch-off points to then explore it more thoroughly. And all the video clips that I've showed, including the ones I didn't have time to show, they're all there on this web page too. So have a look, see what you think, and make up your own minds. Any more questions? It's hard for me to see, which sort of rather proves the point about the bright light sources you see. Yeah, I think we have a question down here.
Hi, I was just wondering, given that everything that's pretty useful to humanity is mined, do they know much about what's going on underneath the surface of the moon?
Oh, certainly, and indeed, in the longer term, I think that would be by far the strongest economic case for a return to the moon, would be to mine the mineral resources present there. But basically, most of the cost and most of the effort in getting the Apollo astronauts to the moon was getting them off the ground in the first place. The Saturn V moon rocket, by far the most powerful rocket we've ever launched, most of the fuel was just to go those first few dozen miles above the Earth's surface. So the chief challenge for the successful exploitation of the resources the moon has is how you can cheaply get it back. Now, my part of the world, growing up in the 70s, what we saw was a huge investment in North Sea oil. That also was extremely costly and very difficult and challenging, but there came a point where we needed the oil so much it was worthwhile making that investment to extract it from an inaccessible location. I think eventually that will happen with the moon, but we're maybe a few decades off that point because there's still plenty of places on Earth where you can access those material resources as well. But I'm an amateur economist when it comes to these matters, but as far as I can see, if there's a demand for something at a sufficient level, then we will do it. Well, if there are no more questions, maybe I can leave you with one of my own, which is to see whether we still have anyone who thinks maybe we didn't land on the moon, or have I managed to change any minds? Okay, mission accomplished, I think, as somebody said from a podium a few years ago. Thank you very much again, and I do encourage you to have a look at some of the resources, think about it for yourselves, and by all means keep in touch, let me know what you discover. And I look forward to maybe meeting you again some point in the future. Thank you. Bye-bye.